Okay, good morning, everyone. My name is Daniele Baldo. I'm the Communications Officer of AgroServ. This is a new webinar in our series where we explore the research happening through the AgroServ project. This episode, we talk about biotechnology and research services that explore biotechnology in the AgroServ project. I would like to welcome Professor Sonia Khoufi from the Center of Biotechnology of Sfax in Tunisia, who is a user in our transnational and virtual access program. With her today, we explore the IBISBA research infrastructures, which is one of the 12 research infrastructures in the AgroServ project. And to that end, we have Diana Garcia Bernet, who is the IBISBA France coordinator, and Mélis Leriou, who is the communication manager in IBISBA. We will start right away with a presentation about IBISBA, a couple of presentations about IBISBA, and after that we explore with Professor Khoufi her project and how the AgroServ project is impacting the research development of Professor Khoufi. So I would ask Mélis to share her presentation now. Yes. The floor is yours. Yeah, we see your screen.
Can you see my screen? It's okay?
Yeah.
Yeah. Okay, so thank you, Daniele, for the introduction. My name is Mélis Leriou, and I'm the communication manager for the European Research Infrastructure, IBISBA. And it is an infrastructure dedicated to industrial biotechnologies. And as you said, Daniele, today with Diana, I'm going to present IBISBA in its role within AgroServ. So I will first give a global overview of IBISBA and then hand over to Diana, who will go into detail about IBISBA France and in connection with AgroServ. So next slide. Yeah, it's okay. So let's get straight to the point, and I would like to introduce my talk by answering the question you're probably asking yourself: what is IBISBA? I don't know how familiar you are with IBISBA, but I'm going to maybe give you the opportunity to know more about it today. So as I mentioned a moment ago, IBISBA is a European research infrastructure with the ultimate goal of offering a unique service portfolio in industrial biotechnologies across Europe. And I would like to say that IBISBA is under construction because it is currently engaged in the European process to become an ERIC. I don't know how many people here are in the anaerobic consortium, but if you are, you may know where we are today with IBISBA. And this European Research Infrastructure Consortium will be a legal status, will make IBISBA fully operational, scientifically, legally, financially, and beyond by 2027 if all goes as planned. So this is the broader context with our medium-term objective, but IBISBA has a long history because the infrastructure has been on the European strategic roadmap for research infrastructure since 2018. So during the period from that day to today, IBISBA has structured itself in nearly 10 European countries. You can see it on the slide. And we call these countries national nodes, and we are working in our case, in France, in Belgium, in Netherlands, in Italy, Spain, Finland, Greece, and Ireland. And these nodes develop IBISBA at the national level by bringing together biotechnology service operators in their respective countries. And this enables IBISBA to work on a unique service catalog that today includes nearly 50 universities and RTOs, at least as many platforms and several hundred services. I can say that from the start, IBISBA has operated with nearly 20 million euros in cumulative funding, mainly from 4 major European projects. And today we continue to position ourselves for European projects because we recently learned that 3 submitted projects will be funded, coordinated by INRAE in France at the IBISBA management team level. And one of these projects will enable IBISBA to launch a transnational access call. So that's, now you know more about the context, and I hope I haven't lost you. But I now like to focus on one of the most important questions, which is, what is the purpose of such an infrastructure, and what are the benefits for our users, whether researchers or industry? And I'm going to develop now about the value IBISBA creates in a strategic sector. As you can see in the slide, biotechnologies represent a major technology for Europe and its competitiveness. And the challenge for the European biotech sector is huge, and numerous reports, including, for example, the European Commission's communication, Building the Future with Nature, Boosting Biotechnology and Biomanufacturing in the EU, published in March 2024, identify biotech as a key technology for the future. And in this context, IBISBA has a coordinating role to play in addressing these challenges, because IBISBA, the objective of IBISBA is to connect a fragmented European R&D landscape by linking research infrastructures and establishing interoperability foundations. And this is supposed to strengthen research capacity in the data and AI era, while adapting services to budgetary realities as well. And the result will be a maximized scientific impact through optimized pan-European resources. For users, what are the benefits? It's maybe the key point. And I can say that this research infrastructure means access to advanced equipment without massive investment and open transnational access. And it will facilitate interdisciplinary collaboration, for data sharing, mobility, open science programs, and ultimately it drives industrial innovations, Europe competitiveness, and better management of complex projects. So how does IBISBA achieve this? The philosophy of work is a coordinated network providing a single access point to cutting-edge pan-European services, including cooperative business development, shared landscape analysis, standard co-development, advanced data tools, and aligned APR strategies. And in practice, this offers pan-European access to expertise, end-to-end interoperability standards, quality project management with continuous improvement, forest project assets that balance openness and security, and training for policymakers. Yes, IBISBA refines service modules as building blocks for R&D workflows, with interfaces enabling research facilities to operate better together, ensuring proven interoperability from TRL 2 to 7. So, oh, what happened? Yes, it's okay. To conclude, I would like to say that even though our major milestone is in 2027 with the ERIC, IBISBA's ambitions go further, supporting scientific reflection on data and innovation. And the goal is to consolidate a European biotech data space by 2030 and position itself as a key player in building a European biotech innovation system. So I think I can conclude now, and Diana, it's over to you for IBISBA France and AgroServ. I have to stop sharing my screen. I hope it will be working. Yes, it's okay. Thank you for your attention.
Thank you, Melis. Thanks a lot. Diana, it's over to you then. If you share your screen. And you're also muted, I think, yes.
Yes, I'm going to share my screen.
Perfect.
Okay.
We see it.
Yes, I will start. So to continue, thank you, Maëlys. I need to change the. Now it's okay. I think now it's okay. Is it
Yeah,
okay
it's
for
perfect.
you? Okay,
Yes,
thank you.
perfect.
Thank you, Maëlys, for this introduction of IBISBA. So now I am going to introduce IBISBA France and also the contribution, how IBISBA contributes to AgroServ, because as you know, AgroServ is really focused on agroecology. So I am going to explain you how biotechnology is also important and can contribute to agroecology. Maëlys presented to us IBISBA. So I am the coordinator of IBISBA France, which is the French node of IBISBA, with the same ambitions and expertise that IBISBA, which are biotechnology and biomanufacturing development. So you can see in the screen that we have currently 16 members, 16 platforms that are members of IBISBA, which are very different from very different domains. Of course, all in biotechnology, but biotechnology that goes from environmental biotechnology. For example, this is the case for Bio2E, the platform that is involved in the project that Sonia will present to us. AgroSolis, and this is a platform which is very recognized at a regional level because they work on microalgae. So really very important for the region of Britain in France. And so this year, last year, we had we integrate a new platform integrated IBISBA France, which is Ferment du Futur. It's a platform which is specialized in food biotech. So you can see that our really now our domain of expertise has grown, has extended to biotech food. And we have also the last one that integrated. The last year, the two other platforms that integrated IBISBA France are Axel One, which is a platform that was originally focused on chemical processes. But as you know, a lot of chemical industries are now shifting or moving toward biosourced or processes, and biotechnology so can be useful for them. And Paris, la Biofonderie de Paris Biofonderie, which is a cutting-edge biofonderie in France. So the expertise domains were presented by Maëlys. The only thing I would like to add is that we work with different microorganisms, bacteria, yeast, filamentous fungi, algae, etc. So we have we work with bioprocesses concerning all kinds of microorganisms. The domains of application, I start to explain them to you. The main domains of application are digital and biomanufacturing, industrial biotechnology, energy and environment, and we are going to see with Sonia an example of project of what we do in environmental biotechnology. Chemicals and materials, and to a lesser extent, food and health, because IBISBA doesn't have, let's say, expertise in the health domain concerning production of molecules, but of course, development of new molecules for the health sector. But of course, the production of these molecules is made possible thanks to industrial biotechnology. And of course, we have an open offer of services for researchers or for industrial partners. And the access to our services is made contacting, via through the one-stop shop catalog of IBISBA. It's a central catalog with all which centralize all the services of all the national nodes. But of course, there are the platform websites. I put here an example of this platform, which is in Marseille. And so you can also access and have the information concerning one specific platform through the website of the platform. And so now we are going to talk about how IBISBA is involved in AgroServ. There is only one platform from the IBISBA network that is participating in AgroServ. Sorry, because as I explained it before, it's a project about mainly focused on agroecology. But biotechnology can serve the agroecology sector. And so the platform that is involved in this in AgroServ is Bio2E, which is a platform working on developing solutions and services on environmental technology for resource recovery from biomass, waste, and byproducts from industrial, urban, or agricultural origin. So this is a platform that is located in South France, in Narbonne. So you can see that our offer the offer of this platform goes from academic research to technological expertise. And so why it's important to agroecology, to have platforms and tools, methods like those proposed by Bio2E, because what is maybe I already presented Bio2E. Why? Because the role of Bio2E in AgroServ is to provide the resources and methodologies that can help to replace the current linear approach that are used for treating all the bio waste and agricultural waste. And so this can allow to reveal the potential of these agro and agri-food residues as feedstock, and to highlight the role they can have in closing loops of raw materials, nutrients, carbon, and water. Of course, today I am only talking about agro and agri-food residues because we are talking about AgroServ, but it's the same with biowaste, urban biowaste. And so Bio2E Bio2E is proposing in AgroServ three kinds of services. The first one is the anaerobic digestion facilities. Let's say anaerobic digestion and composting facilities, but there are several services, anaerobic digestion and composting. So these two services allow to evaluate the potential of agricultural residues to be used, to be treated by anaerobic digestion, and so to be used after that as in composting processes in order to recover, via the digestate. I will explain a little bit later how to recover carbon and nutrients thanks to the digestates that can go back to the soil after anaerobic digestion or after composting, because you can also, you can, after anaerobic digestion, compost the digestates or not. And the third service that we propose in AgroServ is a fully equipped biosafety laboratory, level 2, in which we are able to handle aerobic and anaerobic microorganisms. Because, of course, today I am talking in particular about anaerobic digestion, but we work also with aerobic processes. And so very, very quickly, which are the benefits of anaerobic digestion for agroecology? I was explaining the importance is to closing the loop of the nutrient and carbon in France for several reasons. In France, as in other parts of the world, but these numbers are for France, but the agricultural sector is responsible for a high percentage of GHG emissions, and so which are not essentially, because they are really linked, this methane which is produced is linked to livestock farming, and also to the nitrogen linked to fertilization. So the idea here is to use all the manures and the residues from livestock farming and from agriculture activities through anaerobic digestion, and then use this digestate as a fertilizer. So farmers don't have to buy synthetic or fertilizers from oil origin, fossil origin, and also at the same time we can recover biogas, which can be used for a lot of activities in the farm. And before presenting and discussing with Sonia about the project she is developing with us, with some different biomass, I would like only to very briefly introduce, if I have the time, very briefly another project that is also developed by Bio2E in AgroServ, and this project concerns not anaerobic digestion but composting of, yes, anaerobic digestion, but it's focused more in the composting step. That anaerobic digestion is going to be illustrated by the project Sonia is going to present. And so here, this is a project which is developed with a regional actor of the distillery sector, which is a very important economic sector in the south of France, and it's the distillery Sud Languedoc. And in this during this project, we are developing an innovative method to adapt the microbial communities of the grape, the residue after wine production is composted by winemakers, because it's a very important. The soils in the Mediterranean regions are very poor in organic matter. So for the winemakers and the farmers, it's very important to have this compost that is going to enrich the soil in organic matter. But at the same time, we think that it can be also very important and benefit for the soil to have this, to improve the microbiota of the soil. So that's the project which is currently ongoing. It was presenting during the last during an event held in Lithuania, organized by AgroServ, and so the results are very, very positive. And so that was a quick example of another kind of project that we are developing. And then I am going to let Sonia introduce the project she's conducting with us, thanks to the TNA program of AgroServ. I don't know if there is any question, or Daniele, what do you think? Can we?
Thank you, Diana. Yes, of course, if there are questions, people can write them in the chat, or there's also a Q&A section, so we can monitor that. But I would waste no time now. Sonia, if you want to share your screen, we can dive into your project and continue this discussion on IBISBA's contribution to AgroServ, but now we get more examples of what we can do with research services from IBISBA and beyond, because your project is also, of course, utilizing other services from the catalog of AgroServ. We see your screen now, but not these. Yes, but not the slides at the moment. You shared the browser, I think. Maybe you just have to share probably PowerPoint.
Yes.
In the meantime, I see.
Diana, we have a question in the chat.
Yeah,
Ready
about
to answer,
potential
or?
collaboration. Maybe you can write down in the chat your contact details. So we have contacts from IBISBA, and then I can, at the end of the presentation.
Yes, I will answer in the chat.
Perfect. And then at the end of this meeting,
Sonia,
I will also. Yeah.
Let me know if you have problems too. I can share my screen, Sonia. If you, okay,
No, we have it. We have it. Perfect.
Okay.
Yeah, perfect. Thank you, Daniel, for giving me the floor. Good morning, everyone, and this event. Today, I'm pleased to present our project entitled Eco-Friendly and Nutrient-Rich Biofertilizer for Sustainable Farming, using seagrass rock to improve the quality of anaerobic digestate of local biowastes. Before presenting in details this project, allow me to briefly introduce my institution. I am affiliated with the Center of Biotechnology of Sfax, CBS, located in Sfax City, and established on November 1983. CBS is among the largest biotechnology research centers in Tunisia and Africa, with activities spanning environmental, industrial, agricultural, and health biotechnology. Importantly, CBS is certified in QSA management since 2021, and holds accreditation since May 2024 for selected analytical and microbiological parameters. At CBS, I am working in the field of environmental biotechnology with the Laboratory of Environmental Bioprocessors. Our laboratory is structured around the three main programs. The first is about bioremediation, waste treatment, and recovery of bioresources. The second focuses on valorization of organic solid waste by biomethanization. And the third program is about microalgae biorefinery. In addition to these core programs, our laboratory is actively involved in several international research projects funded by the European Union, as well as bilateral and multilateral cooperation framework. Here in this slide, I give the list of some recent research projects that working in the development and optimization of biogas processes for the valorization of organic solid waste, aiming at renewable energy production and also high quality of biofertilizer. Our work on anaerobic digestion and biofertilizer production directly addresses one of the most pressing challenges in modern agriculture. Today, agriculture is facing major crises driven by soil degradation, rising fertilizer costs, and chemical dependencies. Excessive fertilizer use reduces nutrient use efficiency and create a cycle of increasing inputs for the same yields. This dependency causes greenhouse gas emission and water pollution, while increasing costs for pharma and threatening long-term food security. These challenges call for efficient, environmentally friendly fertilization strategies based on sustainable and integrated approaches. At the same time, large quantities of wastes are generated locally and remain under valorization. As example, food waste, agricultural residue, agro-industrial byproducts, and green wastes. These biowastes represent both an environmental and environmental burden and intapped resource. The waste challenges highlights the need to shift from a linear model to a circular approach to preserve our earth. Among the circular approaches, anaerobic digestion offers an integrated solution by transforming local biomass into renewable energy, biogas that is rich in methane, and nutrient-rich digestate, creating a closed-loop system. Effectively based on several advantages as biomass management, energy security, soil restoration, economic resilience, and environmental protection. So by integrating anaerobic digestion and the need for biofertilizer, the transformation of resource contribute to sustainable farming, circular bioeconomy, and rural development. However, the effectiveness of this circular approach largely depends on the agronomic quality of the digestate, which can sometimes limit its direct agriculture application. In fact, the operating condition of anaerobic digestion as pH, temperature, organic loading rate, hydraulic retention time are the main factors influencing the digestate quality in addition to the composition of feedstock. In this context, the main objective of our project is to develop and optimize a co-digestion process that produces high-quality digestate, offering an eco-friendly alternative to chemical fertilizer. And the innovation AgroServ project lies in the use of food waste and seagrass wrack collected from coastal tourist cities. And we transform these wastes with anaerobic digestion to valuable resources within a circular economy model. In this project, we select the seagrass wrack as the co-substrate because of its high organic matter content, its mineral richness, and its local availability in coastal area. Also, its integration helps the balance of feedstock composition and consequently improve digestate quality. And in this project, to enhance the hydrolysis of organic matter before anaerobic digestion, we propose an enzymatic pretreatment. The work plan of this project is organized into 4 key phases: selection and characterization of biowastes, process development, digestate application in agriculture, and sustainability assessment. However, the implementation of certain activities requires complementary approach and specialized techniques that are not available in our laboratory. For example, fungal strain resources, the characterization of feedstock after biological treatment, the chemical characterization of digestate, phytotoxicity assays, evaluation of the biostimulant effect in vivo model, and the cost-benefit analysis. For this reason, we applied to the AgroServ call to gain access to the corresponding service. This is the concept and development pathway of our project, which has been selected for the second AgroServ Transnational Virtual Access for research projects. So among the 11 research infrastructures at the core of AgroServ, we have been granted access to 4 platforms: IBISBA, Siri, Nutrifood, and AgroEE. Two services are provided by 2 platforms in France, Bio2A and the biotechnology and bioraffinerie environmental, and the Center or the Centre International de Ressources Microbiologiques Champignons Filamenteux. While the other 2 services are delivered by 2 institutions in Italy, Institute of Science of Alimentary Production and the Mediterranean Agronomic Institute of Bern. Specifically, the provided services are access to fungal resources of interest for agroecological research and development, and we have already received 3 strains that are selected for their enzymatic potential in biomass degradation and anaerobic digestion based on strain-specific metadata. The second service is about digestate composting and post-treatment studies. And we here, the stage will allow us to make some analysis, for example, organic matter bioaccessibility, and the choice of the suitable post-treatment for digestate. The third service is about primary production plants. And in this, the service will allow us to make a chemical characterization of digestate, make phytotoxicity assays by germination test, and the evaluation of the biostimulant effect in vivo model. And the final service is the cost-benefit analysis, which is a tool that aids to build scenario to identify the economic feasibility of investment by assessing the cost and comparing them with the benefits. And in addition to these services, technical services, this project will strongly contribute to capacity building and research mobility. Two PhD students are directly involved in the project. To reinforce their expertise, research stays are planned at our partner institution. A 2-month research stay will take place at BUT 2A in Narbonne, France, and a 1-month stay at ISPA in Bari, Italy. During these stays, the students will, of course, receive hands-on treating in advanced bioprocesses, digestate characterization, and agronomic assessment. Beyond the technical skills, these exchanges will strengthen international collaboration, promote knowledge transfer between institutions, and enhance the scientific impact of the project. And finally, in this site, I give the main expected outcomes, which are valorization of local biowastes and seagrass wrack, production of nutrient-rich and stable biofertilizer. I mean here the digestate produced from our developed process, improved soil fertility and crop performance, reduced reliance in chemical fertilizers, circular low-carbon fertilization model, scalable and replicable territorial solution. That is all from my side, and thank you very much for your attention.
Thank you, Sonia. Very, very interesting to hear about your project.
Yes.
Your slides were also, I would say, very comprehensive on what you're doing, what you're planning to do. I would ask Diana, Melis, if you have questions for Sonia, if you wanted to discuss something about her project, her involvement. I'm personally interested in a little bit more on the experience, Sonia, you had so far in interacting with not just Diana, the Bio2E platform, but also the other services. If you want to share something about that, your interaction so far with the 4 actually research infrastructures that you included in the project, and also what is your timeline now about the research? What is the expectations you have on how the project is developing, let's say?
Yes, we started the activities of our project in the mid of September 2025. So we start with some meetings with partners Essentially, the first step was the selection of strains, fungal strains, to be used for the pretreatment of enzymatic pretreatment of wastes. So we received these strains and we start make the fermentation of waste with these strains. And for the characterization of wastes, biowastes, we select food waste as and seagrass wastes as we see that there is a complementary characterization that can make the balance of feedstock in the anaerobic process, and this consequently produce a high quality of digestate. So we make the biochemical methane potential of these wastes, and we are working on the optimization of co-digestion of two substrates. So we will choose the best combination to have at the same time high methane potential and high quality of digestate. So for our interaction with the partner, we start for the plan of the work and the plan of the stay in the mobility of PhD students. We are okay, agree for the period and for the different activities that will be done in their institution.
Okay, that's clear. Thanks a lot. Diana, I don't know if you want to add something. Otherwise, we round up this meeting. You tell me.
It's okay from my side. Sonia was really very clear, and I think she really showed how the TNA program can work in order to serve one research subject, but in order to really develop the subject, the work, I mean, the synergy between the services in all the countries can be possible thanks to AgroServ.
Yes, that's exactly. That's the very interesting point. And to this end, I round up the webinar announcing, because it's recent news, the opening date for the next Transnational Virtual Access Program call, which is opening on March 9. The communication campaign is starting in these days. And I wanted also to bring out the news that, of course, everything is going to be available on the AgroServ website to check the catalog of services. And I also suggest everyone to sign up to our newsletter, which is the best way to remain updated on the project. But from this fifth call from AgroServ, we will be able to receive applications requesting access also to single research infrastructures. This will allow hopefully more people to apply. But of course, we remain committed to transdisciplinary research as with projects as the one that we heard about today from Sonia. Applications including multiple research infrastructures will still be encouraged and prioritized in the evaluation process of this fifth call. With that, if we don't have any questions, ulterior questions from the audience, I would like then to thank all of you. Thank you, Sonia, for joining us. Thank you, Diana. Thank you, Melis.